Hello everybody. Let's solve Leetcode question 1028. Recover a tree from pre-order traversal. So we run a pre-order depth first search on a root of a binary tree. At each point on in this traversal, we output d dashes, where d is the depth and then the out value. If the depth of the node is d, then the depth of its immediate child will be d plus 1, and the depth of the root node is 0. If a node has only one child, the child is guaranteed to be the left child. Given the output traversal, recover the tree and return its root. Okay, let's look at the examples. So we are given this node, we are given the string, traversal string, right? This is a string we are given, and we have to return the node. We have to return the root node after we have parsed and generated recovered the tree from this traversal. Okay, so how will the tree look like? One is the node, right? And at the depth of 1 there is 2, and 2 has two children at a depth of 2, right? 3 and 4. Then we have 5, the other node root, the right of 1, 5. 5 has two children, 6 and 7. So how do we get this tree? So if you take a look at this root node, the depth of this is 0, right? Similarly, the depth of this is 1, the depth of this is 1, the depth of this is 2, 2, 2, and 2. Now, if you take a look at the traversal in the tree, the traversal that we have, the number of dashes before the 1 is 0, right? So 0 dashes. This means this is the root node. Similarly, if you take a look at the dashes before the number 2, there is 1 dash. That means this is at the depth of 1. Similarly, for 5, the dashes before that is 1. So this is also at the depth of 1, right? And similarly, if we take a look, 3 has 2 dashes, so this is at the depth of 2. Similarly, 4, 6, and 7, right? And because this is a pre-order traversal, we know the pre-order traversal follows the following, right? We first find the root, then we go to the left, then we go to the right, right? So this is the order that the pre-order traversal follows. So in that case, we can just find the element with depth 0, initialize it to be the root, right? After that, we find the next, that is depth of plus 1, right? So this has a depth plus 1 dashes. This will be the left node, so 2. Then again, we again do the same reorder. Again, we find the depth plus 1. So there are 2 dashes now, depth plus 1 dashes. So this will again be the left node, 3, right? And after this, we find again is the next depth plus 1. Do we have depth plus 1 dashes? We do not, so the left node of this will be none. Similarly, the right node also will be none. Then we go back to the previous element. Then again we see depth plus 1. So since the depth was 1 initially, depth plus 1 dashes will be 2. So this will be the right node, right? So on and so forth. We'll generate the tree in such a way. So we will be using recursion to solve this. Let's write the code. Initially we have uh, we will need to keep the track of index in the traversal. So let's initialize a global variable self.index equals 0. We will call the helper function. Let's name it recover. We'll pass in the traversal. We will pass in the depth that we are at, initially 0, and we already have index, right? So once this is done, we just return whatever node this gives us. So we just return this. Let's write the recover function. Recover self traversal depth. Okay. So if the length, right, if the index ever is greater than traversal, greater than or equal to the length of traversal, we know that we have parsed everything successfully. We can return from here. So this will return a none. We can be explicit about it. After this is done, let's calculate the number of dashes, right? So let's initialize a variable dash to be equal to 0. So while the self.index plus dashes is less than length of traversal, and traversal self.index plus dash is equal to a dash, then we can increment the value of dash, right? When this is done, if the value of dash is not equal to the depth, then we know that we are not in the correct child node. So we do not have to calculate further. So we'll return none from here. Otherwise, we just set the index to be dash value, right? We increment the index by that many dashes, and now we have to find the exact numerical value that follows. So node value can be in the range of 1 till 1000. No, the value range will be in the order. It can be in the order of 10 to the power 9. So let's write a function to let's write the logic to traverse a number, right? So initially, let's assume the value is 0, while the length of while the index is less than length of traversal, and traversal at the index is a digit. Value equals value times 10 plus numerical value that we are at. Okay. And we will increment the index plus equals 1. Okay. So once we have the numerical value, we just create a node from this value. So node equals the node, we pass in the value, and node dot right, node dot left, node dot right. So node dot left will be the same recursive function. So let's call the recursive function again, self dot recover, pass in the traversal. We need to pass in the depth. So the depth of the left node will be depth plus 1. Similarly, the depth of the right node also will be depth plus 1. Once everything is done, we need to return the node. Let's run the test cases are passing. Let's submit it. Accepted. Thank you.